substitution method, also known as u substitution for indefinite integrals. Objectives: by the end of this lesson, you should be able to recognize when u substitution should be applied, find the u in u substitution to change the variable, complete the substitution method to solve an indefinite integral. Okay, so a lot of people consider integration to be harder than differentiation for this very simple reason. In differentiation, it's all kind of straightforward, right? If I tell you to take the derivative of this guy, you're like, oh, you're multiplying two things, product rule. If you want to do something like this, it's a quotient rule. If we don't have that, we have no set rules for integration. In integration, it's either the basic rules or we have this thing called use of the substitution method. That's what we're going into here. Right, so we don't have all the same rules we did back in derivatives. All the chain rule, derivative, all that stuff. Now we got basic rules, a little bit of reverse chain rule, and then now the u sub. Let's look at this first example to get an idea of what's going on. So here it's saying, hey, when you take the derivative of sine x squared, right, this would be a chain rule. You take the derivative of the outside, the derivative of sine's cosine, leave the inside alone, and then you times by derivative of the inside, which is 2x. So we would get like something like this, leave the inside alone, then times by derivative of the inside. That's what they have right there. So when we're going backwards, right, when you integrate, we got to go backwards. So how are we going to go from here to there? How are we going to go from 2x cosine x squared to just sine x? That's when we do substitution method. So right here, let's talk about it. It's this guy. Yeah, it means no sense to me either, right? I mean, I get it because it's like math talk, but that's not really going to help you. What's really going to help you is this method here. So first step, once you know it's a u sub, you want to identify what your function is, a u of x. What's the inside function type of thing? It's commonly as the inside function or the function on the bottom of a fraction. Looking for u, you're often also looking to find its derivative and modified derivative inside the integram, but it's not always the case. That's just a way of saying generally it's the inside function, right? Or the higher power. But your first goal is look for the inside function. If it's a fraction, look for the bottom order. That's what's mostly going to happen. Sometimes I do something special, but that's what's mostly going to happen. So let's get back to our example here. My u here is going to be x squared. Right, it's inside this cosine. So I'm going to put u equals x squared. Next step. Next, find du by taking the derivative of u. Du dx and then multiplying the dx on the other side. So that means this. So we have u equals x squared. Now let's take the derivative of both sides. So now the derivative with respect to x. So derivative of u, if you remember our implicit differentiation, is just 1 du, wrong variable, so dx. Derivative of this side is the right variable, right, with respect to x is just 2x. Now the goal here is once it's solve for dx. So once I do this, I want to get dx by myself. So remember, first step, find u. Second step, once you got u, take the derivative of both sides. Now you want to get dx by itself. So a little algebra. We're going to multiply both sides by dx. So right here, I'm going to go dx, dx. These cancel out. I get du equals 2x dx. Now again, I want to get dx by itself. So I'm going to divide by 2x. And I have du over 2x equals dx. And then before change of variables, we're replacing the function in derivative du du. So what we're doing here is this. So let's rewrite everything now. So 2x hasn't gone away. That's still there. That's cosine. And now instead of x squared, I'm going to have a u. Now here's, right here we have dx. Now remember, I solved for dx. So what we're going to do is we're going to replace that dx with what I solved for. Du over 2x. So right here, instead of my dx, I'm going to put du over 2x. Now, if we're lucky like we have here, notice what happens. The 2x and the 2x cancel, and you just get the integral of cosine u du. And that's very important. They both have to be the same variable. So right, if I saw that x here, something went wrong, I messed up my u sub. They all have to be the same variable. So cosine u du. And then from here, just integrate. Integral of cosine is sine u plus c. And the last step, plug your u back in. Sine of x squared plus c. Which is what we had up here. Right, and that's the last two sets. Evaluate the integral with respect to the variable u. If solving an indefinite integral, replace c with the original substitution. So that's the process. So this, let me run it back one more time, right? So the idea is you have this function, find your u. that's x squared. Take the derivative of both sides, du dx equals that side. Try to get dx by itself. So I got that right there. Now you plug everything in, right? 2x is still there, cosine still there, that's a u now. Instead of dx, it's this guy. Do a little math. Now you just integrate like normal. After you integrate it, plug your u back in. And that's it. That's u sub. So let's do some examples. Okay, first step, find our u. Like generally for the inside stuff, also higher power is also a hint. So my u is going to be x cubed. Let's take a derivative of both sides. Derivative du is du dx. Derivative x cubed is 3x squared. Solve for dx. Multiply both sides by dx. Divide by 3x squared. You're going to get this. You notice most times just switch these two. Du over 3x squared equals dx. Again, how did I get that? All I did was, okay, I want to get dx by itself. Multiply by dx. These cancel, and then I divide by 3x squared. So I get this. Now once I have that, let's plug everything back in. So it's going to be integral. That's an ugly integral. 3x squared. Cosine. That's a u now, right? Again, plug the u for that. Instead of dx, very important step right here, we're going to plug in this guy, du over 3x squared. Look at that. My 3x cancels out. That's great. Now we have the integral. It's a little better. Of u du, which is just sine of u plus c. Last step, plug your u back in. So it's going to be sine of x cubed plus 3. It's that easy. Next one, I get another u sub. Right there's going to be my u, right? The thing on the inside. So my u is going to be x squared plus 3. Take the derivative of both sides. Du dx equals 2x. If you haven't noticed by now, right, all you're going to do is multiply by dx and divide by 2x. Really just switching these two. So du over 2x equals dx. Now let's plug all our guys back in. Integral sign. Oh, I'm still working on that, guys. X. Now remember, this is all u now. So it's u to the 5th. That's a bad parenthesis. Dx. Oh, sorry. Not dx. I was looking at my bad parenthesis. I forgot about the proper thing we're supposed to do there. Right? Instead of dx, let's plug in our substitution. Du over 2x. Now in this case, look, only the x's cancel. I still have a 2 down there. That's fine. Remember, if it's a constant, you can pull it out. So we have this. Du. Now we just integrate like normal. Add 1 to the power, divide by new power. So plus 1 over 6. And then you can multiply these two to get u to the 6 over 12 plus c. And we're almost done. Remember the last step, plug your u back in. Easy thing to forget, but please don't. I don't want to fail as a teacher. So we get that. Right, and that's all it really is. We're going to do this a couple more times to make sure we got it, but that's the general idea. Okay, right here. Integral of x e to the x squared plus 1. So as you hopefully could guess, my u is this guy. There he is. U is x squared plus 1. It's a plus, and that's a 1. That's a plus. So now we take derivative sides. Du dx equals 2x. Now remember, all we're really doing is switching these two guys because it's called cross multiplication, but whatever. You're going to get du over 2x equals dx. Now let's plug everything back in. So it's going to be integral, slightly better, x e to the u du over 2x. Right? I plug this guy in for the dx. The x's cancel out again. I'm going to get the integral. And again, I have a 2 there. You can pull it out. So 1/2 integral e to the u du. Integral of e to u, just e to the u. Easiest integral there is in the world. Plus c. And don't forget the last step, plug your u back in. So plug it back in for this guy. So I'm going to get 1/2 e to the x squared plus 1 plus c. Okay, so those are all we did 3 real quick that were basically the same thing, right? Just find your u, take the derivative both sides, swap it, get dx by itself. Now you can plug everything in for your integration. Stuff cancels out, hopefully, and just integrate like normal. Let's do one that's a little trickier. Tan. If you notice, we haven't learned tan. Integration for tan, we don't know it. I don't know it, right? So how do we integrate tan? And there's no real u sub, like do I make u tan? That doesn't make sense. It's a little tricky. What we're going to do is we're going to use our trig skills. We're going to make tan sine over cosine. Remember, sine x over cosine x. You can't just have a sine and a cosine. It has to have an x with it. So I have sine over cosine. And now in this case, I'm going to make one of these two guys my u. Remember what we said earlier? It's like it's the inside function is higher power, but what if it's like that? Like which one's higher than which one? Which one's inside? If you're not sure, it's generally the denominator, the bottom of the fraction bar, also known as denominator. So over here, I'm going to let u be my cosine. Don't let me down. So u is going to be cosine x. I'm going to take derivative both sides. Derivative du is 1 du dx. Now remember, we're doing the derivative cosine. Derivative cos are negative, so it's negative sine x. Again, as always, try to get dx by itself. Let's multiply by both sides, divide, yada yada. You're going to get this. Du over negative sine x equals dx. Now let's rewrite everything. So this is going to be integral sine. That didn't change. Cosine became a u. My dx became du over negative sine x. Stuff cancels. These cancel. These cancel. And you get negative. Right. I pull the negative out. Integral of 1 over u. That's my good. That's a good integral for me. Over du. Now we get to integrate 1 over u. So real quickly, integral of 1 over u. Everybody? Yeah, natural log. I can hear you. So integral of natural log plus c. Now plug in your u. Last step. Integral of natural log of cosine. Yeah, that's weird. I know. It's the way it goes. Plus c. There you go. That's my integration. Integral of natural log of absolute value cosine plus c. Again, this is why I don't memorize the integration of tan. It's not normal, to say the least. Okay, one more of these ago before we go on to a couple AP assorted multiple choice questions. Now this one's actually a very special one. I'm going to refer back to it in class. It's kind of a special one, so I'm going to put a little star here. That's a star, don't laugh. Kind of hard too. So let's do this one. Again, there's no real rules for integration, so I'm just going to do what we always do. I'm going to find my u, which is by now hopefully the inside thing. So u equals 5x plus 1. Take the derivative signs. Du dx equals 5. Get dx by itself, so multiply it over and then divide. Du over 5 equals dx. Now, there's a problem with this one, if you haven't noticed right now, right? There's nothing to cancel out the x. If I rewrite this, I'm going to get this. Integral of x. Let's rewrite that to 5x plus 1 to the 1/2 power. That's the only way we could take integral of this. So it's going to be integral of u to the 1/2 power. Du over 5. Right? I cannot integrate this right now. There's an x, there's a u, it's madness. I got to have only u's or only x's if I want to integrate. So that's a problem. And now we have to talk about how do we solve it when this happens. When there's a wrong variable. Well, the key is this. Anytime that happens, like you did u sub, but there's still an x that didn't cancel out, you go back to here and you solve for y, for x. Solve for x. So we're going to get x by itself, and then we're going to substitute it in. To substitute. So I'm going to solve for x here. I'm going to subtract 1. U minus 1 equals 5x. Then I'm going to divide by 5. So u minus 1 over 5 equals x. And I'm going to plug all this in for that x right there. So I'm going to have this now. Integral. Kind of bad. U minus 1 over 5 times u to the 1/2 du over 5. I know what you're thinking. That's not much better. It looks bad. It does. But it's actually solvable. That wasn't the case earlier. So let's do this. Let's pull all the constants. There's a 5 on the bottom, 5 on the bottom. We're going to get 1 over 25 integral u minus 1, I should put parentheses here, it's bad math grammar, u to the 1/2 du. And this is actually, I could actually solve, it's actually not that bad. Next, we just distribute this. That's a bad arrow. And then when you distribute, add the power, so like this is u to the first plus u to the 1/2 times negative u to the 1/2. So I'm going to get this. 1/25 integral u to the 3/2, right, because this was u to the first plus 1/2, so 3/2, minus negative 1 times u to the 1/2 is this negative u to the 1/2 du. Right, so again, ugly, granted it's ugly, but doable. Next step, we just integrate this. So, right, we're going to add 1 to our power and then divide by our new power. 3/2 plus 1 would be 5/2. Add 1 to the power, divide by our new power. 1/2 plus 1 is 3/2. So then we get, I'm going to move over here for space, 1/25 bracket. Now remember the trick is you can bring the bottom one number to the top here. So it's going to be 2 u to the 5/2 over 5 minus, again you can bring 2 to the top, 2 u to the 3/2 over 3 plus c, can't forget that plus c. And then we're almost done. I know it's ugly, but we're almost done. Plug your u back in, right? The final step. So it's be 1/25 bracket 2 5x plus 1 to the 5/2 over 5 minus 2 5x plus 1 to the 3/2 over 3 plus c. Now again, you can stop there, right? We're doing, this is a free response question. I am done. I am out. And that's how you do it. Again, so one of the main point of this problem was if you're doing a u sub and you don't get rid of all the variables, again, they all have to be the same variable. So I can't have a u and x hanging around together. I gotta get rid of that x. And the way you do it is you go back to your original u and then just solve for x. So here, just gonna solve for x, subtract 1 divided by 5, I get that, plug that in, and now you can solve it. Again, still ugly, but solvable though. Okay, let's almost done here. Let's get to the final couple questions. We're just doing a sort of AP questions just for practice. So here's an example, right? It's multiple choice. So here we actually got to simplify to make it look like one of these guys. We have this. So basic u sub. Let my u be the inside thing. U is going to be x cubed. Take the derivative both sides. Du dx equals 3x squared. Solve for dx. I'm going to multiply it over and then divide. So you basically just get this. If you haven't learned by now, shame on you. Right? So I get that. Now we're going to plug it all in for there. So I'm going to have integral x squared cos, that's a squared, cosine u. Instead of dx, I'm plugging this guy in. Du over 3x squared. That my ugly x squared there and my x squared here cancel out. I could pull out the 1/3. 1/3 integral of cosine u du. Integral of cosine u is sine. Remember we're doing integration, so it's opposite, it's a positive sign. So you get 1/3 sine u plus c, which makes, plug our u back in, 1/3 sine of x cubed plus c. Find the one that matches, and there I go. Didn't fall for a negative, blah, 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 blah. That's our first one. Our last problem. So we're going to do this one. And again, let's pick our u. In this case, if it's a fraction, it's generally going to be the bottom one. Not always, but generally, like 95% of the time. So our u is x squared minus 4. Take the derivative side, du dx equals 2x. Solve for dx, right? Multiply, divide, so you get this. And now we're going to plug everything in. So rewrite it. My integral is going to be x over u du over 2x, because I plugged that in for the dx. These guys cancel. Pull the 1/2 out. 1 over u du. Right? Integral of 1 over u is natural log. So 1/2 natural log of u plus c. Plug your u back in. 1/2 natural log of x squared minus 4 plus c. Find that one. There we go. Done. That's the lesson in under 20 minutes.